Good morning. My name is Toni Broquetas. I'm professor from the Polytechnic University of Catalunya, and I'm going to present you a course on radar systems. This is the outline of the course. We will present with the basic objective of the radar, radio detection and ranging. Then we will talk about the electromagnetic waves and objects interaction. We will define an important parameter, which is radar cross-section. We will follow with the determination of two important parameters in radar, which is range and velocity. Then we will talk about radar detection and an important aspect, which is a clutter, which is an interference that we have to reject in radar. And we are going to do this with coherent processing. Then we will also present the angle determination, which is going to depend on the parameters, radiation diagram parameters of the antenna, and we will finish with a synthetic aperture radar technique. Just as a way to introduce a few milestones, historical milestones of the radar development. Actually, Maxwell introduced the theory of electromagnetic waves, which was verified later on by Hertz. And in his experiments, Rudolf Hertz actually was observing the interaction with the electromagnetic waves and objects. Some years later, at the beginning of the 20th century, Christian Hulsmeyer actually presented the first pattern of what we can consider a radar. At this time, it was called a telemobiloscope. In the 1930s, the radar was reinvented by several countries, actually as a consequence of the pressure of the defense needs. Actually, an important milestone is the improvement of the magnetron, the first power magnetron in UK in 1940. And then after the Second World War, actually some important technology and technique advancements were carried out. One of the most important, it was a synthetic aperture invention by Carl Wiley. And then this technique has been applied in a number of airborne and satellite platforms. NASA actually launched in 1978 a CSAT, which was the first spaceborne SAR. And in the present century, we have several important missions. Two of the most relevant is the Shuttle Radar Topographic Mapping mission and the Tandem X mission, which have the same purpose, which is obtain a high-resolution topographic map of the whole planet. Okay, let's compare at this point a radar with a wireless communication system. A wireless communication system, which is here at the first half of the slide, has the mission to transport information. So actually we capture information from a source. We actually provide this electrical signal with a transducer, and then after some processing and emitter, we are able to transport this information at a long range. A receiver actually does the opposite as the transmitter, decodes the radio frequency signals and obtains finally what hopefully is a faithful reproduction of the original signal or information. In radar, we use the same technology. You see, we have also emitter, receiver, processing, detection. This is the same processing blocks that we have in a wireless system, but the purpose is totally different. In a radar, the objective is not to transport information, it's to obtain information. So here we have the objectives, target detection, location, velocity obtention. We want to reject clutter. Clutter is objects that we don't have interest in clutter, but it provides interfering signals for the radar. We want to eliminate clutter. And then some radars are able to classify the target and even to obtain images of the target. We will talk about this during the course. Let's start with actually what is the basics of radar. Basics of radar is the interaction of electromagnetic waves with objects of interest. Then what we do in radar is we transmit a signal, a radio frequency signal, and then once this signal reaches the target, the target is actually any object of interest, can be whatever, an aircraft, a drop of water for a meteorological radar, it depends on the application. Once this signal illuminates the target, we can model the interaction with induced currents on this target, which is responsible, or which are responsible for an echo production. And then this echo is actually propagated back to the radar, and the radar contains a sensitive receiver, which actually is going to extract information of the object from the echo which is received here. So this is the basics. Then let's talk a bit on the technical aspects which are related to this system.